Hello, innovators. I'm Todd Wyant, and welcome to the Bridging the Gap podcast presented by Applied Software Great Tech Group. You're invited to join our conversation to model the future of construction innovation and the digital transformation adventure of this great industry. My guest today is Stanley Stoll. He's the CEO and principal engineer at Knott Laboratory, with extensive expertise as a board-certified forensic engineer and expert witness. He began his career as a design engineer, eventually finding his passion in evaluating and repairing damaged structures, leading him to the field of forensic engineering. A former airborne combat engineer in the U.S. Army, Stanley now oversees Knott's engineering divisions and is a recognized leader in building assessments. Welcome to the show, Stanley.
Yeah, thanks for having me, Todd.
So I always like to start with how you got into this industry to begin with. What's the origin story?
Yeah, origin is started in construction at like 14, and started building homes with, dad's buddy and progressed from there. Did some time in the service, which was a lot of fun. I was actually an explosives expert in the military, so we did more demolitions of structures than building of them, but that was fun. And then after the service, undergrad and graduate degrees in structural engineering. And first company I worked for was in Louisville, Kentucky, where I got my graduate degree. And we were just working on a lot of existing buildings at that time, strengthening parking structures. We worked on some hospitals. I got to work on a lot of the water companies' facilities at that time frame, which were, these are 200-year-old buildings that they're evaluating for, seismic upgrades and things like that. And just really enjoyed the existing buildings and the complexity of what those existing buildings brought forth. There's nothing that we were learning in school that was this is exactly how you do it. It was a very figure it out on the ground, how to improve this building, what's going on with it. And yeah, I just kind of fell in love with it at that stage, and then wanted to get back to Colorado, where the opportunity to continue to work in existing buildings came through a forensic company, which was Knott Lab at that time. So, and then, yeah, just kind of continued.
Yeah, that's awesome. I'm curious, how did the experience with demolition and explosives with buildings, how'd that translate over to what you do now?
Yeah, I think it's certainly a lens of my life that I got to see. I don't actually do a lot of like blast design or anything. I think it would be fun to do that because that was, we were trained to take down bridges. We were combat engineers, so taking down bridges, breaching buildings, breaching doorways, breaching even dirt, like things that were preventing tanks from rolling into cities and stuff like that. Those were our breaching tools that we were doing. So there's not a ton of application in our world. The closest thing is like blast design or something like that. Yeah. And I haven't done a ton of it. Yeah.
Yeah. I was just curious.
Yeah.
So when you're coming in to assess a building, how do you go about really being able to identify those potential pitfalls and problem areas that could lead to tragedy if unaddressed? How do you kind of spot those out just by walking around?
Yeah, well, if I could speak to this just for a sec. So NCSEA, we're working on an existing building series where we're doing a webinar series on how to do building evaluations. And one of the themes that we've come to, and the reason for that is because it's basically largely dependent on experience. Like, we learned so much in college. We learned how to build buildings. We learned all about material properties and all of that stuff. But then once the building is out in service and now it's been impacted by the environment, now we have all kinds of things that change. We have loading conditions that change. We have degradation of materials that happen. And then, the building may settle. That induces its own forces on the building. So we're dealing with a lot of different situations that are hard to anticipate and probably not, in the calculations. We're not designing a building new with an intended settlement of one side of the building. That's not something we're designing for. And so with one of the things that we're trying to do through this series is just increase the education and experience level of all those engineers out there who are doing building assessments or get asked to do them. And so how do we identify those? It comes from lessons learned and things that we've seen out in the field. Obviously, we've witnessed Surfside collapse, and the reports are coming out on how that happened. The NIST report is coming out hopefully within the next 6 months or so, and we'll see their official findings. But that's a series of multiple factors that happened that culminated in the failure. And what we as engineers is very challenging as we're figuring out. But we as engineers have to figure out the sequence of how those things could come to be to allow the building to fall. And a lot of times that's coming from like a progressive collapse type of sequence. You lose lateral support for a column or a wall, something that's bracing a column that without this second level parking structure bracing it, now all of a sudden that column is 50 feet tall. There's no way it has lateral stability in that type of mechanism. So if you lose that lateral stability, then that's going to be one of those components that can lead to these progressive collapses. Probably, something that was a contributing factor to the Surfside collapse, the ultimate building collapse down there. So,
So to kind of double click into that some, what are some of the maybe kind of key leading indicators that you're looking for to be able to identify it? Because I imagine some of when a building collapses, it's might be easier in hindsight to go, yeah, this domino down, but how do you catch it early to then come in and create the necessary repairs?
Yeah, you're looking for, I mean, and this is in hindsight, but also applied very much to any of our building assessments that we walk into. You're looking for displacement, of displacement, cracks, anything like that. So if you have concrete that is separating from a wall, this is you're starting to get these separations where it's no longer connected. If you're seeing crack formation in like punching shear is something that's very spooky for us. And so if you're seeing radial cracks that are extending out from a column, and these are in say a parking structure, then those can be consistent with a punching shear. There's not enough steel reinforcement for how that concrete is tied to the column. And so if you're seeing these radial cracks coming out from that can be something that's very concerning. Separations of any connections. I think connections are the biggest concern, because connections are something they're a shear failure. They're going to be an instantaneous failure. They're not something that's, like a beam will deflect and you'll be able to see that deflection, but there's redundancy in that beam. Like a concrete beam, if the cracks show up in the center span of that beam, that's we get that. But the steel is going to start to stretch, and we're going to have redundancy in the connection and the capacity of that beam. But when you're at a connection to a column or something like that, those are shear connections. You don't have that warning sign of, oh, it's going to bend, it's going to bend, it's going to bend, and you have time to see that bending before it actually fails. Right. So if you're seeing connections that are showing distress, cracking, maybe steel that's pulling out of concrete, things like that, those are going to be more significant issues that you're trying to pay attention to.
Can you share maybe some examples of kind of the proactive problem solving in the building assessments and how they prevent significant issues? Or how do you even tangent question, how do you kind of prove the preventative measures did actually prevent something, and it wasn't just kind of you taking action where it would have been fine either way? Does that make sense?
Yeah. Well, they're interesting, right? Because you get you get in these situations where on the preventative situations, you come out, you identify something, and some things there's some things that just make your hair stand up on the back of your neck, and you just
Mhm.
know this is really spooky. You know the loading conditions. You know it's heavily loaded. You know that you're seeing some distress. Whether it's truly going to fail is always extremely subjective, and that's something that as structural engineers we're trying to figure out. You're not trying to throw up red flags for something that is, it's at 50% capacity or 25% of or chance of failure, right? Like
Mhm.
you're not trying to throw out things that are scaring people, like your building's going to fall down when there's not those spooky circumstances. So an example of one situation that we've dealt with was it was a punching shear. So this is I think it's a 4-story building, and then 2 stories of parking structure underneath that building.
Mhm.
And there was known issues. There was known deficiencies in the steel reinforcement that was in that concrete in those parking decks. And we got brought in kind of later. We were hired for another thing, and kind of got brought in and they just wanted an overarching perspective of, hey, is there anything else while you're wrapping up this scope of work? Is there anything else that you want to take a look at, or should we take a look at? And we had heard that, well, we've heard that there's issues with these parking structures, but we've never looked at them or anything like that. We went down and looked, and the cracks that existed in those, they all radiated out from the column, and they had been repaired. But what they did for a repair back at the time when they discovered them was they just routed them out. So they just ground them out, and they epoxied those cracks. Well, by the time we get there, these cracks have lengthened, they've gotten longer, there's a lot more of them, and the original structural deficiency that existed had never been repaired. And
Mhm.
so this is probably one of the most serious situations that I was involved with, as far as, we brought a team of senior engineers together. We're all looking at this. We're all analyzing it, going, how bad is this? We don't want to falsely alarm a community. There's lots of people that are going to be mad at us if we, tell them to close their parking structure and or evacuate the building or whatever, as we're trying to deal with these circumstances. And ultimately, we were there. The analysis showed that these are under designed from begin with, and these cracks are they're showing the failure of it. And
Mhm.
so, we recommended to the board, like, you've got to get some shoring in here to support these things. I mean, funny story, they were so mad at us. They were, we gave them a letter. We said, look, this is a very serious issue. They basically said, look, you're fired. Like, we'll find another engineer. And ultimately what happened is they went through a couple of engineers and eventually came to the same conclusion that we did. And they ended up fixing it, or putting shoring in place and then fixing it.
Mhm.
But it's a delicate situation when you're going in and trying to inform somebody. It's a lot of money that we're going to tell them to spend that nobody wants. They don't want the inconvenience of closing off their parking structure. It's in an area where there wasn't a whole lot of parking around as well. So it's a big pain. And
Yeah.
so anyhow,
I'm very curious about this. So how do you then get the buy-in from the needed people, where it's for sure an inconvenience? It's money that they weren't expecting to spend. Maybe they don't even visually see the, big problem there. Like, what's the big deal? How do you get that buy-in and support of recognition that, no, this, you need to solve this now and get to work?
yeah, I think it's so one of the IC, there's a board president of ICC that spoke after Surfside collapse, and one of the comments that he makes is that this is a human issue,
Hmm.
and that people actually addressing issues and having maintenance funds and things like that to address these things are very, it's difficult. And so to your question, it's communication. We have to convey to them like, look, we really are seriously concerned. This isn't us trying to, to cover our tail that if something bad were to happen, you can't sue us. Like, it's not that. Like, we truly have, serious concerns about the condition of this building, and here's why. And so we have to be able to communicate that at a technical level. Those are the calculations behind this are very technical. So we have to be able to convey the deficiency in the design, and then tie that to, look, if you have this deficient design, the structure should be doing this. It should be showing cracks just like what it is.
Mm-hmm.
And we've run all of this analysis, and you've made it to this point in time. This building is, I don't know, 5-6 years old at this time. You've made it to this time, but we don't know. It may last another 5-10 years. It could last 20 years, but it could also fall tomorrow. And that falling tomorrow is the problem. And you have you've got moving traffic, you got vehicles on the level below, you got vehicles on this level that are moving
Mm-hmm.
through this. The right loading conditions, we don't know exactly what that's going to be, but one of those things is going to trigger this thing to go. So it's a human issue. It's a communication issue, right? Like, we have to convey
Mm-hmm.
trust that we have done a thorough analysis, and we do have legitimate concerns. And I guess the other thing is, like, pull in other opinions. We tried to do that with our team to convey, like, look, this is not just one engineer's opinion. This is a team of engineers who have looked at this, and we've all come to the same conclusion. And we're not just giving you this information for, to cover our tail. We're giving you this information because we have serious concerns. So I think it's conveying confidence in our analysis, and then communicating that effectively to the client.
Mm-hmm. Yeah, I mean, I think you nailed it with the building trust component of it. If they don't trust you, they're not going to listen to you, no matter how clear you communicate the problem. You have to really be very intentional about building that trust to then
Right.
have that listening ear.
Right.
How do you prioritize the actions to help bring clarity to potentially really complex situation where maybe there's multiple areas that you need to tackle, but how do you go about prioritizing and figuring out the overlapping issues?
Yeah, in general, I mean, the severity and what can happen from if you don't address these issues. I mean, so we're normally looking at, if we're doing a complete building assessment, we're doing a prioritization list of repairs for them. So we're trying to give them the resources to look, if you only have X amount of money, this is where you need to be focusing those resources at first. And then if you have additional resources, then these next tier of components. And so for us, that is, we're continually working on that messaging of that and that tiering structure. What we've been playing with, and ASCE has done this, is they use a grading system. So they use A's to F's.
Mm-hmm.
And all of us know, we can all go back to, first grade, kindergarten. If you got a red F on your paper,
It's not good.
It's not good, right? You kind of know that, right? And so we've been playing with that type of tool in our grading systems to help people understand the magnitude, especially when we're talking to non-technical folks. Reinforcement and the size of reinforcement, corrosion in concrete, deterioration in concrete, substantial structural damage. None of that means anything to, the little old lady who's sitting on the board of the community, right?
Right.
But
you see your eyes glaze over probably.
Right. But if you've got a D or a D minus or something like that on there, that's understandable. And so we're using tools like that to help prioritize. And then what gets classified into those grading systems, we kind of have our own that we're continually working on to better message it and stuff like that. But anything that's pushing towards those life safety concerns, where if this did continue to fail or continue to degrade, then you're going to get into a precarious situation where you may have a partial collapse, or you may have a collapse in total, anything like that. So So those things are getting pushed towards those D's and F's, and then the better parts of the building we're using, push it towards A's and B's.
Mm-hmm.
It's funny because nobody really cares about the A's, but everybody wants to know that there's something good on their building. And so this is something interesting that we've discovered is we can't negate that there are good parts of the building. But really why they hired us was they want to know about the C's, D's, and F's, right?
Right.
They want us to really evaluate those, but they feel bad when they don't have something that's at least a B. It's an interesting dynamic. So
you got to do the sandwich effect then,
right.
lead with the good, then come in with the bad, and then go back to good there.
Right.
It's the
Exactly.
human psyche there.
Yeah, exactly.
That's funny. So I imagine that one of the big F's would be when water comes into the building. What kind of danger would water really pose, and how do you combat it?
Well, water it's almost always associated with a failure. It's degradation of our buildings. So whether that's in the form of snow or it's in the form of water, wind driven rain, things like that.
Mm-hmm.
And then even we think about water coming through roofs, we think about water coming through balconies and corroding out or deteriorating out, say the ledger that the deck is being held onto the building with, or water grading and drainage around a building. And now you have water that's pooling back or running back to the foundation. That's also the cause of settlement, settlement of soil. In Colorado, we have a lot of expansive soils, so the water saturates the soils, and then the soils actually heave up on the structures and lift them up. So water is always our problem. And I had no idea, going through structural engineering school, that water was going to be my biggest adversary in actual practicality, but it is. So, and it's one of the things that we kind of preach upon as far as preventative maintenance. Water is such a big problem because, if you look at any concrete structure, look at parking structures, things like that, when water is not managed and drained properly into the drains and away from the buildings and things like that, you end up with it going down into the concrete, causing corrosion of the reinforcement, causing degradation of the concrete itself. In freezing climates, you get water down into the concrete, it freezes, breaks the concrete apart. So water is this huge problem. And so anybody that sees any amount of water that is pooling in areas where it shouldn't be pooling or infiltrating into a building, your biggest bang for your buck is to get that stopped as soon as you know about it, because it's only going to get worse from that point going forward.
Yeah. What are some of the common mistakes that building owners make regarding water management?
Delay of action is the one piece, and I think just the lack of acknowledgement of the seriousness that really that is. As I'm speaking this, I'm trying to think of other things that are as serious in nature as far as causing degradation to buildings, and I'm struggling to come up with things that are of significance. Water is going to cause that. When we look in the forensics world, fatalities and things like that are the biggest threat, and so and that's what's driving the life safety components of our building codes and our inspections and things like that. And so one component of where water plays a big role is like exterior wood structures. And you get water coming into decks and balconies and draining into, say, the connection point between that deck and the exterior of the building. A lot of times water can get trapped right in there on your ledger boards and rot those out. It's a shear connection that can be hidden behind, above soffits and things like that. Maybe you've got some moisture staining and things like that down on the bottom that show. Most times they're really showing, but sometimes that can be hidden up in there and causing this hidden decay, where that reaches a point where at some point it's going to fail, and you're going to lose it, and it's a shear failure. And once that comes down, then the whole thing comes off the wall. It's been the result of serious incidents, with buildings, and just one example of it.
So in general, what would your advice to a building owner be in terms of building safety and trying to make sure, everything is operating effectively and as it should?
Number one would be controlling that moisture. So if you see some moisture stains, you see some bubbling paint underneath soffit materials, you see moisture coming in at the roof, you see deteriorated concrete on the bottom side of concrete parking structures and things like that. If you've got moisture stains on the bottom of the concrete and you've got rust coloration coming from that, that's most likely the moisture is coming in, causing your steel reinforcement inside that concrete to deteriorate, and it's rusting and it's now continuing through and pouring through. So you have degradation of the steel reinforcement inside the concrete. So anytime you see any type of moisture intrusion into buildings, you've got to get to the root cause of that. It's going to be some sort of flashing issue, some degradation, some caulkings. It's maybe the grading and drainage has changed such that the soil has subsided and now the water flows back towards the building where originally it flowed away.
Mm-hmm.
Find out what's causing that water to come into or towards the building and correct that issue.
Okay. So as we start to land the plane here, a couple rapid fire questions for you. What is the phrase modeling the future? What does that kind of bring up in your mind? What does that look like to you?
In my context, as far as like building assessments and existing infrastructure, it's modeling out the critical inspections and things like that we need to be doing, and the maintenance that we have to be performing on buildings to, one, make sure they don't fall down, and two, extend the service life of those buildings is how it pertains to me, at least.
Yeah. Okay. One of the big topics that we talk a lot about on this podcast is around innovation. What does innovation mean to you?
Well, innovation is to me, I absolutely love it, and we push a lot of things. Innovation is basically stealing or acquiring from other industries something that they're doing and applying it to our industry. So if you allow, so in our world, that's laser scanning. So using 3D laser scanners coming in and modeling buildings. I've always talked about how working with existing buildings, everybody wanted to take an existing building and then put it into 2D plans with repairs. And it always drove me kind of nuts that it's 3D. We have photographs of it. Like, do we need to put it into 2D plans to show it? Just put your repair on the 3D picture, if nothing else. And it's so much clearer to everybody who's working with it. With 3D laser scanners, you have the ability to capture the built environment, capture that building, capture that parking structure, do all kinds of measurements with it and see if it is deflecting. You can put water on it, see where water runs and all of this stuff. But you're back at your desk and you have a digital twin of what's out there on the site that now you can work with in so much more detail than we have been able to before.
Yeah, I love that. Totally agree. We think and we see our world in 3D, so our plans should be in 3D whenever possible. I had a former boss that used to call that R&D, rip off and duplicate. So I love that. It's always stuck with me. If you see somebody doing something great, rip it off and duplicate it and make it your own.
Absolutely. Absolutely. Yeah. Yeah.
How do people find out more information on what you got going on and connect with you?
So Knott Lab is the company, Knott Laboratory. KnottLaboratory.com is our website. And then, it's a forensic engineering company doing all kinds of very meaningful and very meaningful investigations. Something generally went bad if we're involved. And we're always trying to take those lessons and then pour those back into others as a preventative maintenance. Like, that rolls right into that preventative maintenance thing. And then as far as the webinar series that we're working on with NCSEA on just helping to educate, I mean, it could be for anybody. It's focused on structural engineers, but it could be for anybody on the tangible issues that we come across in the field. Like, what are those, not the obscure things that rarely happen, but what are the regular things? Some of the questions you were asking, what are those regular things that we come across that we need to be addressing on a day-to-day basis, and then training others on how to see those and then make the appropriate recommendations off of those. So yeah, either the company or LinkedIn, we're all there. So
Where do they find the webinar series? They just go to the website?
Yeah, the webinar series is through NCSEA, National Council of Structural Engineering Association, and it's being run right now. It's a 6-part webinar series that we're into presentation. We've done 2 presentations, and they're recorded, so you can access past presentations, but there's 4 to go. And then they are going to be hosted at the Live Summit in Las Vegas in November. It's half a day, 5 hours, that is specifically focused on existing buildings and this exact topic. So
nice.
We'll be down there talking more.
Awesome. Love it. Final question for you. If I could give you all construction power, you could snap your fingers and innovate one thing, what would you pick to innovate in the industry?
I think we do a good job of our building codes and building safe buildings. I don't think we do a good job of maintaining our buildings and our infrastructure. So it would be starting to push out more of the existing building code, more of the property maintenance code, just trying to get that out more into awareness of the transition goes from architects and engineers and contractors who designed and built these buildings. Now it's turned over to owners and facility managers. Now it's their job to pick up on these things and, kind of pick up the torch and run with it, but keep that building running with the same kind of critical eye that was put on the original design process. So it's influencing and empowering those and making better decisions with the existing infrastructure.
Yeah, I love it. Makes a ton of sense. Stanley, thanks so much for taking the time and joining the show today.
Yeah, thank you. Really appreciate it.